Welcome back to Outward Home Learning. This is computer science and today we're looking at binary shifts. So to explain what binary shifts do and the effect that they have on a number, we're going to go over to Mr. Holton, who's going to explain it all, and then you've got a task followed by an exam question to complete. Over to Mr. Holton.
We'll go over binary shifts, and honestly these are nothing to be afraid of. They are very straightforward. Once you get them in your head, you'll be absolutely fine with them. They're all about how computers can multiply and divide numbers. I'm going to go through a few examples with you. You'll need to really understand the whole binary to denary conversion to follow along with this video. So if you haven't seen the binary to denary conversion video, please make sure you watch that. But if you have watched that, you'll know what I'm doing right now. I've got a binary number here. I want to figure out what the denary value of it is. So there you go, 0, 1, 1, 0, that equals 6. All right, let's start shifting. So there's two bits of information that I need to give if I'm shifting. The first one is the direction I'm going to shift it in, so shift left. And the second one is the number of places. So I'm going to say shift left, one place. And look what happens. I'm going to basically move all these numbers left one. And that means I'm going to spring a 0 into existence here. Okay, so you'll see what happens now. So 0, 1, 1, 0. So you see how everything's moved up 1. So that 0 is now there, that 1 is now there, and so on and so on. I'm just, as it sounds, I've shifted it left one place. But what's happened to the value there? Let's find out. So if I do 1, 2, I haven't left myself a lot of room here, 4, 8, and 16, then you'll see that that's doubled, hasn't it? So I've gone to 12. All right, okay, so that's quite useful. Let's find out what happens if I shift left now 2 places. I'm going to leave myself a little bit more space. So it's 2 places. So I'll do this in a slightly different color so it's a bit more obvious later. But I'm going to start off with 0, 0. Then I'm going to repeat this pattern. So 0, 1, 1, 0. And you see what's happened. I'm shifting this one to be really clear. This is what I'm shifting left 2 places. So this 0 now has moved to here, as you would expect. This one now has moved to here, and so on and so on. What's happened to the values? Let's find out. I've got 1, I have to do this underneath, 2, 4, 8, 16, and 32. So that is 24, which means I've multiplied my original number by 4. A shift left one place has effectively multiplied the number by 2, and a shift left of 2 places has multiplied the number by 4. You can probably guess if you shift left 3 places, then you'll end up multiplying by 8, 4 by 16, and it doubles just like the numbers above here double. So because you're working in binary. So if you remember how that works, then you'll be able to do any shift to any number of places fairly comfortably, I would think. All right, so what happens if we shift right? Well, you've probably already guessed that shifting left multiplies. So if you shift right, then you are dividing. Okay, so it's that simple again, and it's following the same sort of number system. So I'm going to focus on this one up here. This is what we are shifting right. I'm going to shift that right one place, and look what happens. I've got 1, 1, 0 now. Okay, so 1, 2, 4. So I had 6 originally. Shifting right one place is giving us 3. So that has effectively divided it by 2. Okay, so divided by 2. That's the computer science divide symbol. Can't break that habit, unfortunately. All right, but what happens this time? If I shift right 2 places, what happens next? Because that gets interesting, because all of a sudden I'm going to lose some accuracy, and you'll see what happens here. We should be able to figure out here that if we're doing it by 2 places, it's going to do it by 4. So it's going to end up dividing the number by 4. And this is what we end up with, 1, 0. 1, 0. Now that's a problem, isn't it? Because I'm going to get the result 1. 6 divided by 4 isn't 1, but I haven't got any way of doing a decimal place. So if I shift right and that causes a 1 to drop off the end of that binary number, then I'm going to suffer a loss of accuracy. I'm not going to get exactly the right result. And that really is all there is to it. Binary shifts, done.
So it's now time for your first task. In the first task, it's called binary shifts activity. Surprisingly enough, you need to complete some binary shifts, and then you need to talk about the effect that has. So you've got 10 minutes to complete this task. You might need a little bit longer, so you can pause the video if you need to, and then we will review the answers. So 10 minutes starting now. Okay, so that's time up. We're now going to go to Mr. Barnes to review the answers.
Okay then, so here's activity all based around binary shifts. So it's going to want the shift answer in binary and then what it is in denary. So we've got here, perform a right shift by 1. So I like to think it was a cliff edge, and it just bumps it over, and if it's a shift of 1, one of them falls off the end. So that means you end up with 0, 0, 1, 1, 0, 0, 1, which is obviously in 7 bits, so we'll make it up into 8 bits by padding it back out with the on the left hand side, which is where we lost. So what is that answer in denary? Well, we've got 1, 2, 4, 8, 16. So we've got 16 plus 8 is 24, and that is 25. Okay. And then we've got a left shift by 2. So we're going the other way this time. Imagine my cliff's the other way. So we're going to end up with 1, 1, 0, 0, 1, 0, 0, 0. And we've got 128 plus 64 plus 8. So 128 plus 60 is 188, plus the 4 is 192, plus 8, we've got our answer of 200. Okay, so we do a left shift by 1. So we've got 0, 0, 1, 1, 0, 0. So we're going to end up with 0, 0, 1, 1, 0, 0, and then a 0 on the end. Okay, so my number now, we've got 1, 2, 4, 8, 16. So our number is 24. Okay, and then we've got a right shift by 3 finally. So again, my little sort of cliff, the 3 fall off. So we're going to end up with 0, 0, 1, 0, 1. So that's 5 bits, and we're going to have 1, 2, 3. Okay, and again 1, 2, 4. Answer to that is 5. Okay, so what are these shifts actually doing then? So does a left shift multiply or divide a number? Well, it multiplies by 2 for each shift. Now, what problems do left shifts cause? Now, let's imagine we've got an 8-bit binary number here. So we've got an 8-bit binary number that equates to, I don't know, let's use that one at the top here, 200. So imagine we've got 1, 1, 0, 0, 1, 0, 0, 0. Well, that's 200. If we left shift it once left, okay, it should be 400, because I've just said it multiplies by 2 for each shift. So my left shift number would become this one here. But actually, that is 128 plus 16, 128, 138, 144. So my number's gone from 200 to 144. Well, that shouldn't happen. But why has it happened? Well, because it should be 400. But in 8 bits, we can't represent 400 because it's more than 255. So sometimes when you left shift, the answer becomes more than 255. It therefore gives the wrong answer because it cannot be represented in 8 bits. Okay, so what problems do binary right shifts cause? Now, let's do a very simple example. Let's take this last number here, which was a number 5. 3, 4, 5, 1, 0, 1. Now let's shift that right one, so that should divide it by 2. So it becomes 0, 0, 0, 0, 0, 0, 1, 0. Well, that becomes 2. So 5 divided by 2 is 2.5. So what does sometimes happen with a binary shift? Well, it loses, start that again, loses accuracy because the number may result in a decimal and it can't be represented. Okay, now beyond GCSE, you can look at things like floating point binary, so you can actually represent binary numbers in decimal. But for the purpose of this, we're dealing in whole binary numbers, and that means that you lose the accuracy because it loses a decimal place. So there's your answers for the binary shifts activity.
So it's now time for the exam style questions. You've got about 8 marks worth of questions to complete binary shifts with. So we're going to give you 10 minutes to do that, and then Mr. Barnes will review the answers. Okay, so as ever, that is time up. Please make sure that you make any amendments you need to make if you didn't get those 100% correct. So we'll go to Mr. Barnes now.
Right, let's have a look at these exam questions then as part of our deliberate practice on binary shifts. So we've got here question 1A, complete a two-place right shift on the binary number 11001011. Right, so a two-place right shift means the two furthest right numbers drop off the side. So it becomes 1 1 0 0 1 0. But we don't leave it as a 6-bit number. So with those two ones that have dropped off the right, because we've shifted it right, we then need to pad out the left with 0, so it still ends up as a 8-bit number. Okay, so next question says explain the effect of performing a two-place right shift on the binary number. Well, I'm going to say that when you shift a number right twice, it divides by 4. So each shift divides by 2. So move it right 3 times. It divides it by 8 because it's to the power of. This can lead to a loss of accuracy if the result is a decimal. Okay, so this question was 2 marks, so just saying, it divides it by 4 is only going to pick up 1 mark. So I've said it can lead to a loss of accuracy if the result's a decimal. So obviously if you had a number like 63 in binary and you shifted it right once, well, that divides it by 2. So 63 divided by 2 is 31.5. Well, it can't represent 31.5 with an 8-bit form, so it gives the incorrect answer because it can't deal with decimals. Anyway, right, let's carry on. Question 2A then is complete the table below to show the effect of performing a two-place left shift on the binary number and the denary equivalent. So it wants us to convert them to denary and also then perform a shift and then say what's happened. So here we've got the binary number 10101101. So if I was writing this on my binary number line, I've got 128, I've got 32, I've got 8, 4 and 1. So 128 plus 32 is 160. Plus 8 is 168, plus 4 is 172, plus 1 is 173. That's its denary equivalent. Okay, so now I'm going to shift it left 2 places. So it's the opposite of what's happened before. The furthest 2 digits to the left will drop off the end. So I will end up with 1 0 1 1 0 1. But then I need to pad out the zeros to the right this time with 2 zeros because I've shifted to the left. So if shifting to the right divides by 2 each time, 2-place shift to the left should multiply by 2 each time. So we've got 128, 32, 16 and 4. So what we've got here, 128 plus 32 is 160, plus 16 is 176, plus the 4 is 180. Well, that should have multiplied 173 by 4, but it hasn't. So explain the outcome of the shift. Well, I'm going to say the number should be multiplied by 4. That's what should happen. So 173 times 4, 346, 692, I think, off the top of my head. So it should multiply it by 4, but we can't represent 692 with 8 bits. Okay, so the number should be multiplied by 4, but the answer is incorrect, as the correct answer is above 255, which is the maximum number, or the highest number even, you can represent with 8 bits. Okay, So now we've done those questions, let's go through and have a look at these answers. So get my answer sheet. So question 1 then was a simple 1A was a simple 1 mark question which says just perform a binary shift. So the correct answer is 0011 0010. Perfect. So that's that mark. Nice and easy. Okay. Question B then. So it's 2 marks this question. So I've said when you shift a number right twice it divides by 4. So the number is divided by 4. Correct. This can lead to a loss of accuracy. The bits on the right are removed. Well, that's the other thing you could have said, but I've said a loss of accuracy as I explained with decimal numbers. Okay, moving on. Let's move up. So next up we've 3 marks here. So we've got to perform the shift and find the denary equivalents. So the denary equivalent is 173, so that gets me 1 mark. For the next one, it should be 10110100. Yeah, that's right, for another mark. And the denary equivalent is 180, so that gets me my 3 marks. And then for the final mark, oh, too far, I need to, similar to the question before, explain the outcome. So it's 2 marks, so I've said the number should multiply by 4, be multiplied by 4, 1 mark. And then it's got here, but it gives the wrong answer because the maximum number is 255. 2 marks. And there's your answers for binary shifts.
And that is everything you need to know about binary shifts for computer science. See you next time. Well done for taking part.